Okay. So the first question that you just said, we'll be dealing with a two-dimensional matrix. So let's say that we have int r, c, and give us the these give us the number of rows and the number of columns in the table or in the matrix. Let's say that we have uh, or
Your screen is not visible.
okay, is it not visible? One second. Uh, is it visible now?
Yes.
Okay. So as I was saying, we have R and C, and this will tell us how many rows and columns are in the matrix. So we can just put it like this. And now we have then R. Yeah. So int less than I less than R, I plus plus, and then we'll have a second for loop in here. And sorry, j equals 0, j is less than c, j plus plus. Is this correct, or should it be the other way around? Okay, so the exact wording we'll be able to understand if we just take a look at the student document or the grading document for this term. Yes, this is a student handbook. Okay, now 1 second. Okay, so over here, if we go to C programming, okay, so over here it is given like this. SCT will have to be completed. OPPE2 will be available for those who are scheduled, who are eligible for interim, and the score in your assignments should be greater than 40. Okay, yeah. So yeah, you even if you like don't give both of those OPPs, yeah, even if you don't give both of the OPPs in the next term, you can just give the OPP and that way, I guess. No, this is the annexure. This is for Python programming though. Oh, 1 second. For OPP, it should be up here. Yeah, right here. So lab, let's say OPP 1 and 2, you let's say are absent for that one, and term you give, and if you pass the total, in that case you can just yeah, you have the option. You can give only the OPP in the next term. Yeah. So yeah, it's possible. You can. It's fine. The C lab you can register for a different day, I guess. I can, but yeah, you can just give the OPP in the next term. Okay. So coming back to the question at hand, as I asked, R stands for row and C stands for column. So is this the correct interpretation? Like, is this how it should be? Okay, so yes, this is how it should be, because we are going to be changing the column more frequently than we will be changing the rows. The rows only will change when we finish one column. So this is the correct interpretation. And over here we can just do scan f percentage d comma and matrix I j. Is it clear what we are doing over here?
Yes, sir.
Okay, so this is simply the reading for the matrix. Now for the main question. So let's say that not even printf, let's just do a void function. Let's say that I run a function and I name that function uh, border sum, and in that I just give the matrix as the input. I give the matrix. Let me say how I should write this function.
Your voice is breaking, sir.
Border sum.
Your voice is
And
breaking.
okay, is it better now?
Yes.
Okay. So my question was, what should the parameters be of this function?
Like first we take the sum of rows.
No, like the parameters. That's the first step, right? So why is this coming like this?
We have to give the size.
You have to give what? The size, right?
Size.
So can I just do R and C over here? Okay, fine. I'll just do it like this. This is going to be in star. Let's say this is Matt. So how will you do it now? Okay, so we have the address of the first element, and you have the size. Sorry, you have the number of rows and the number of columns. How will you take care of this? Okay, before anything, tell me how I should read this. Am I audible? So tell me how I should read the values first. What is this, guys? You're not interacting at all. Come on, tell me what should I do after this? I am audible, right?
Yes, ma'am. Now we take the sum.
Uh, how will we take the sum?
Like we have to find the sum of the rows and columns now of the
No,
boundary
I
side.
understand that. That's the question, right? So how will we arrive at the solution? So I have one loop over here. Is this enough to read the values?
No, we have to take one more loop for the column also.
We have to take one more loop for the column also, right?
Hmm.
Okay, I guess I had a bit of a lag spike over there. Am I audible now? Okay. So as I was asking, what should I do now? How will I read the values over here? Keep in mind we are having a pointer over here. So how will we read each value? Okay, fine. Before that, just tell me what is the condition? Like, how will we figure out if something is a border element or not? So, let's say, uh, just ignore this. This is something I was working on before. So, let's just say that we have some like what 5 by 4. We have a 5 by 4 of this one. So, can anyone tell me what is the property of the border elements? Like, what differentiates it from the inner elements? Take a smaller one, for example, A11, A sorry, A11, A12, A13, A21, A22, A23, A31, A32, A33. So can anyone tell me what are the border elements in this matrix?
A11, A12, A13, A21, A23, A31, A32, A33.
Okay, so can anyone tell me what is the fulfilling in this case? Like we have two parts, right? Let's say that this is Aij. So what is the condition that I is fulfilling?
I should not be equal to 2.
Are you sure about that? Okay, so notice one thing. What is common in this part? What is common over here?
I
And what? It's simple.
Your voice
Just
is
look at
breaking.
the elements and tell me what is the value of I. Am I audible? Okay, so tell me what is the value of I in this row?
1,
It is 1. What is the value of I in this row?
3,
It's 3, right? Now tell me, what is the value of j in this row? Sorry, in this column.
1.
It is 1. What about in this column?
It is 3.
It is 3. So can't I just do this? Wherever I is either 1 or 3, or j is 1 or 3.
Yes, we can do that.
We can do that. Now, 1 we understand. What is 3? 1 is the first row in the first column, that much we understand. But what is 3 in this case? It is the last row in the last column. Okay. So let's say that we have 4 by 4 matrix. What would the value of this be? What would this be?
4.
It would be 4. Now translate that into computer language. Translate into C. Because in C, if we have, let's say, 4 by 4 matrix like this, then what is the range that I can be? Let's say that this is I. I can be from, it can take any value from 0 up until 3. That's right. And similarly, j can take any value from 0 to 3. Okay. So what would the border elements be?
1, 4.
No, no, see. If it goes from 0 to 3, then where would you find a fourth? Uh, so it looks something like this. Sorry. A00, A01, A02, A03. I hope I don't need to draw the rest of the table.
Hmm.
So tell me, what is the last first row and column and the last row and column?
A40.
Sorry,
Last one. Last column. A40.
I'm asking the number. Which number will denote the last column?
3.
Correct. So the last column is 3. And what's the first column?
It will be 0.
It will be 0. Similarly, what will be the first row?
0.
It will be 0. And the last row?
3.
3 again. Correct. So if I have, let's say, an n by n grid, so what will the value of the first row be? Let's say that I have a n. It is going up until some value k. So what is the value of the first row? Sorry, the first column.
N minus 1.
No, no, I'm asking the first column. What is the value of the first column?
Zero.
Correct. It's 0. And the value of the last column? Go ahead. You
N
can say.
minus one.
That is correct. It is n minus 1. So the same thing applies for this one, right? This is 0 and this is n minus 1. Okay. So did you understand how we are going to find the border elements?
Yes, we can now use row minus one or column minus one. Yeah?
Yeah. So now we just need to translate that into code. So we are reading the elements right here. So what should the first thing be? What should the first part be? Okay, tell me what should I be?
For J,
Sorry?
for the column one,
No, 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 no. We are checking this one. What should I be? Whether we are first checking whether or not the element given is a border element.
I will be zero.
I equals 0 or
Row will be greater than one.
sorry, sorry, I could not get you.
Row greater than one. R greater than one.
No, 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 no. What's the last row? We just discussed this, right? If we want
N
a
minus one.
border element, then we want the first row and the last row. So what should be here?
I is equals to N minus one. Or
Do we
this
have
row minus
n
one.
anywhere?
No, so we can write row minus one.
Sorry,
R minus one.
r minus 1. Correct. Or what else should be there?
If J is equals to zero,
Okay. And
J is equals to column minus C minus one.
c minus 1. Okay. So with this, we are checking if any of the given element is a border element. So now let's say that we found a border element. What will we do after that?
We all add all of them.
Okay, so how will we do that?
At first, we have to declare the sum.
Okay, in sum equals 0. Now
Now, sum plus is equals to
sum plus equals,
A.
sorry, we do not have a anywhere in the code.
Like matrix
We have a
star.
pointer. Keep in mind we have a pointer. We do not have a matrix.
Star matrix.
Sorry, I guess I got disconnected for a bit. But yeah, we have a pointer over here. We do not have a matrix. So how will we get to the elements? All right.
Yes, sir.
So just tell me, how will we get to the elements using pointer arithmetic? Any idea on how we should do this? Okay, so tell me. Let's say that I have a small matrix over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3 by 3 small matrix. So now how is this stored in memory? So let's say I have a few boxes over here, 9 boxes. So how is this stored? Don't worry about endianness. Just tell me, how is this stored?
Line wise 1, 2, 3, 4.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this you're telling?
Yes.
Okay, so now tell me, what is the coordinate of this one in this matrix? Like which elements are these ones?
Which one?
1, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Correct?
Yes, sir.
So now tell me, what is the position of each of these? Like in memory, what is the position of each of these? Let's say that this is the first one, 0. So what would the others be?
One lower to higher.
1, 2, 3, 4, 5, 6, 7, 8. Correct? So now you tell me, keep in mind this A, N, N, where N equals 3. Okay? So now come up with a formula where this is satisfied. Where this, we can get this from this. Where we can get the position from the matrix location.
So I didn't understand that.
Okay, so let me just put it clearly. So let's say we have two, M and N, where M is, in this case, M and N both are 3. So first see, we are going column wise, right? So N is changing first, right? So that is our least significant. So we can plus N right there. Now, when we change M, let's say that we are going from 1 to 4. then what is the change that we are seeing? From 1 to 4 we went. Went from 0 to 3. It is a difference of n, right? Or let's say that we are going from 2 to 5. If we are going from 2 to 5, we are going from position 1 to 4. And the difference, like the size of this jump, it is equal to n. Like think about it. Let's say that we had one more row of, I don't know, 10, 11. What would it look like? 4.
But yeah, your voice is breaking.
And then the bottom positions they follow. So now, if we are going from 1 to 4, what is the size of the jump? We are going from 1 to 4. What is the size of the jump in memory? It is equal to 4, right? And in this case, n is equal to 4. Is that understandable?
Yes, sir.
Okay, I'll just give you the formula. You try to justify it. Okay, m times n plus n. Justify this formula for me, or disprove this formula, whatever you like. Okay, fine. Just if you're unable to understand it, just think of it as a formula. Whenever you have a pointer and you want to find the location in it, and you have a this pointer leads points to a 2D matrix, just simply do this. So j into I plus 1. Okay, just remember this as a formula if you cannot understand the logic behind it. Now then, if we just do printf percentage d, so now the code should work. Let's just see. Let's say we have a 3 by 4 matrix. Okay, so we have this one. So this is the matrix that I gave it. I just try to make it over here. So I gave it a 3 by 4 matrix. So A is equal to A 3 by 4 is there. So then let's just say it is like this. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. Okay. So now we have 1 plus 2 plus 3 equals 6, 0, 1, 2 equals 3, 6 plus 9 equals 15, 4 plus 7 is equal to what? 11. So what's the total over here? We have 17 plus 3, 20, and plus that 15. So 35 we have. And what do we get? 30. Something is wrong. Okay. Okay, so can anyone tell me what may have gone wrong over here? Just for completion's sake, let's say that it interpreted this as what, like this. No, even then it wouldn't. Okay, 1, 3, 6, 10, 16, 23, 32, 33, 35. Is this the input that I gave? Okay, just 1 second. I'll just print out the matrices. Okay, no, no. Okay, so that's what's happening. Okay, so we just have to replace R with C. That's all. This is what I was talking about before. Only changing one. And now if I run the same thing, okay, it's going somewhere else. Why is it like that? Yeah. So now it should be good. Yeah, now it's okay. Okay, so did you guys understand like how we found the bordering, how we found the border elements in this line, and in order to take the sum, and how this works? Like finding the elements of a 2D matrix using pointer arithmetic. Did you guys understand how this works? Okay, not an issue. Um, just try this problem on your own. This is a good exercise for this one, the matrix, 2D matrix or 2D array. So just try this problem out on your own. And other than that, As I have said before, just forget out week 11, it is not necessary. Week 7 to 10, these 4 weeks, practice as much as you can, because these 4 weeks are it's the syllabus, you can say. And yeah, just practice as much as you can, because question, the questions will include topics from all of them. Okay, other than that, you guys still have your timed assignments, so make sure not to miss these. Like, these are graded. Okay, so these things, do not miss them. And the first one, just keep the deadlines in mind, because this one, it is 9 p.m. Okay, so I'll just end the class here. Go ahead and do your timed assignments and prepare well for OPPE 2. Okay, yeah, thank you all for being here. Thank you all for joining the session. I'll I'll stop the recording now.